durability test and other tests on coarse aggregates here. Right. So moving to this here, durability test is actually also called as the soundness test. So this test is used to determine the resistance of an aggregate to disintegration by saturated solution of sodium sulfate or magnesium. This test is very easy, but it will take some time consuming because we need to we need to insert in the solution and later on we need to transfer it to the tray, so that whatever the weathering action taking on the aggregates, that is in terms of durability, will be determined here to determine the weathering action of the aggregates. So you can see below here the image, you can see how the whatever the aggregates, stone aggregates have undergone some action, weathering action. So the apparatus required are a sample container, a weighing machine or a weighing balance, hot air oven for drying of the aggregates, immersion tank, later on coarse aggregate, and a sodium sulfate, and minimum mass of salt per liter of water. So here you can see the containers here. That is a sample container, magnesium sulfate, right? So this just they are shown in the wire basket. So just you see the so just you can see here, the aggregate sample has been taken here, and later on here is our magnesium sulfate here, and later on this is a small wire basket for taking the aggregates and also the whatever the solution there, and another is sodium sulfate. So sodium sulfate is like sodium sulfate is somewhat like a crystal forms, right? So it will be similar to the salt crystals, and a sample container will be transferred to the a wire basket, a bigger wire basket, whatever I shown you during the specific gravity and water, that can also be used. So 1 kg of coarse aggregate is taken in the sample. That's the first step. And this sample is immersed in the sodium sulfate. So how you immerse in the sodium sulfate? That sodium sulfate should be taken in any small, big containers or buckets and all. So that's sodium sulfate. So it is taken out from the solution, then dried in oven and later on cooled. So should to dry in oven and later on cool. That's why we need hot air oven for drying the whatever the aggregate sample. And immersion, drying and cooling process is repeated for 10 complete cycles. So what we need to do, immerse in the sodium sulfate solution for 24 hours, oven dry it and cool it. So immersion, drying and cooling, immersion, drying and cooling. In that way, we have to do 10 times. So it is 10 times, 10 complete cycles should. So finally, retained weight on the sample, like here you can see W naught is the initial weight of the sample what you are taking before immersion in the sodium sulfate. Final retained weight on the sample containing after 10 cycles. Means what happens, the same sample, whatever 1 kg of sample is been taken, for example 1 kg of sample taken in a wire basket, and that wire basket, for example I'll draw it better in a better way, wire basket, and if there is any bucket or any tub which has been filled with the sodium sulfate here, so we will immerse, you will immerse these aggregates within this wire basket in the sodium solution, and later on you will transfer it into a tray, you will do an oven drying, and later on you will cool it, right? So in that way, the same aggregates 1 kg, that should be repeated for another 9 more times. So what happens during these 10 cycles, some aggregates may undergo weathering action. They may break into pieces or they may disintegrate themselves. Means any aggregate, if I take any aggregate, so they may disintegrate or they may undergo weathering. In this way they happen. So at last we'll be left with only some aggregates. That is W1, final retained weight on sample container. So in this container, on this basket, whatever left out aggregates, good aggregates, that weight to be taken, that is W1. And the simple formula is percentage loss, that is W naught, initial weight whatever was there 1 kgs, that minus whatever the other weight left. For example, last you are getting some 200 grams of weight, so 1000 minus 200 divided by 1000 if I do, so 800 divided by 1000, that will be 0.8, that is 80% is the percentage loss. Here you can see like 100 grams and later on 82 grams. So 100 minus 82 divided by 100, 18%, which is less than 25%, means they are acceptable. That is 25% is the standard given by the that is IRCs or other agencies particularly. So what happens if the aggregates whatever you're using, if its percentage loss in the durability test or soundness test is less than 25%, then those aggregates are suitable for road construction. In this way, you can tell the suitability of the aggregates based upon durability test. So other tests like coarse aggregates are stripping value test. So this stripping value test is mainly conducted to know the adhesion property with the bitumen. So bitumen adheres well to the normal types of aggregates provided they are dry and free from dust. So to determine this, we need to conduct stripping value test. And some other two more tests are there. Actually, I'm not getting anywhere about detailed procedure. So that is iteration and iteration test is there, and another is stone polishing test. Those two tests I will be discussing at the last. No need to worry, right? So I'll be discussing that. And this is the last table. That is nowhere we have come across the tables, right? All in a one. So this is a table one, which is what are the tests for aggregates with the IS codes, and what is the type of the test, and what is the property of the aggregates we'll be getting from that test. So clearly you can see here that is property of aggregates. Just a minute. No, very less number of students have joined. I'm not understanding why. Yeah, the same link, right? Okay. Yeah, moving to here. So for example, crushing value test. So what will come to know? Crushing strength property will be coming to know. See, why I'm explaining these properties in the, because if you go to, if you write any competitive exam, they may ask this type of questions in your multiple choice questions. Even if you go through whatever you should go through in detail about the topics. So then only you can easily write the descriptive part and also objective type. So coming to the other test like Los Angeles abrasion, I can say Los Angeles abrasion will tells us the hardness property. Next type of test, abrasion tells us the hardness property. Aggregate impact value test will tells us the toughness property, right? Next, the soundness test or durability test, we say accelerated durability test, which tells us about the durability, that is percentage of loss. Shape test will tells us the shape factor. What is the shape factor? That is in terms of thickness, I can say in terms of thickness, in terms of length, right? L length, and in terms of length, and in terms of angularity A, right? And whatever the specific gravity and water absorption test, another type of test which tells us about the specific gravity and the porosity or water absorption capacity of the aggregates. Stripping value will tells us the addition to the bitumen. So these are the types of test, and with respect to that, what are the property of the aggregates can be known from those tests, and these are the Indian standard codes you can refer to, right? So this just put a small slide. Traffic studies, actually I've shown you the apparatus, just I want to show you. So traffic volume count, whatever the apparatus available in our laboratory is, these we say it as tally counters. So this is still more visible here, you can see this is how the tally counters will be there. So this is the button. If by pressing that, the count will be added here. So tally counters, so these are very easy. Whatever the during the count of the vehicle per hour, vehicle per minute, or vehicle per second, if you want to know the number of vehicles moving on a road, using this tally counters you can easily count the vehicles, different classes of vehicles, I can say. And this is the spot speed apparatus, that is radar gun, which shows the speed in kilometer. It's like a gun, that's why the name has come as radar gun. Usually what happens, whatever the gun, so this button, whenever we press it, and whenever the light emits from it, whatever the moving or passing object, that will be hit by this ray, and that will be taken back, that will be received back. So this whatever the Doppler effect we say, based upon the Doppler effect, we'll be knowing the speed in kmph. Even we can know this speed in also other units, that is miles per hour also in this. So that's it, and this is the observation for spot speed. This I already discussed. Yeah, I'll move to the next. It is test on bitumen. Not wasting much time here. So I'll be sharing a short notes with you. No need to worry. Whatever the highway material testing is there, that is test on soil, CBR, plate load test, and later on test on aggregates. So I have a short notes with me, which already been prepared for laboratory purpose. That short notes I'll be sharing with you. If you go through that short note is also more than enough. Yeah. So moving to the next is test on bitumen. So before that, you should know what are the what is bituminous binder and what is bituminous mix and what is bitumen mainly. So I'll be moving to the first introduction and later on I'll move to the test on bitumen here. So the bituminous materials are, one is bitumen, another is tar. Just a minute, I'm seeing the syllabus of yours. Like in the syllabus he has given like a test on bitumen, and later on he has asked to introduction to modified bituminous binders. Yes, that's what I'll be first discussing, the test on bitumen. Before that, I'll be discussing what is bitumen, what is tar. So bitumen and tar, these are the two bituminous materials. Bituminous, whenever I say bituminous material is semi-viscous, we say, not viscous, semi-viscous. So these, what are the uses of this bituminous material? Are used in surface course of a pavement, as already I've shown you in the components of flexible pavement, and used in, sometimes used in base course also of flexible pavements to withstand relatively adverse condition of traffic and climate, and used in soil bitumen stabilization also. So you'll be studying about the stabilization maybe in your GT, or else you'll be studying in detail in your pavement design subject, if it is there as an elective through from the JNTU. And later on it is used as sealing material for filling the joints in cement concrete pavements. What happens whenever you have seen a cement concrete pavement, whatever the white topping you see, the white roads you see, those are the cement concrete pavements. Mainly, it will be having the this type of slabs. I can say, sorry, I couldn't draw bearing correctly. So, for example, this is a cement concrete slab. It will be actually having four slabs. I can say four slabs. So these slabs will be having the joints in between, transverse joints, longitudinal joints. So to fill these joints, this bitumen is also used as sealing material. Right. So what is bitumen? Bitumen is some hydrocarbon material of either natural or pyrogenous origin, we can say. And as already said, it may be in a gaseous form sometimes, whatever the gas fumes coming during the heating, liquid, and it is a semi-solid or semi-viscous, we say. And later on completely soluble in carbon disulfide and carbon tetrachloride, just for the information. Next, preparation of a bitumen is obtained by the fractional distillation of whatever the petroleum crude. So from the petroleum crude, because of the fractional distillation, we'll be getting the bitumen. And the color of the bitumen is black in color. Coming to the preparation, you can just go through this preparation. This is as much, this is not needed. So just remember, the bitumen is obtained from the fractional distillation of petroleum crude. So what are the desirable properties of a bitumen? So that whenever I talk about the desirable properties, you should remember, as already discussed for aggregates, in that way, some desirable properties are also mentioned for the bitumen also. So coming to the bitumen, viscosity is one such property of a bitumen which is very important. Like viscosity of the bitumen will tells us the time of mixing, and also compaction should be adequate. So depending upon the viscosity of the bitumen, we can decide the time of the mixing, because viscosity is something like which directly tells us the resistance to flow. If the resistance to flow is more or the viscosity is more, then what happens? We can say it as it is not a soft bitumen, and the mixing time may be more in that way. So this is achieved by heating the bitumen and aggregate prior to the mixing. Other desirable properties, like bituminous material should not be temperature susceptible. Yes, this is the next important desirable property of a bitumen, because tar is not used because of the temperature susceptibility nature. Tar can easily catch a fire at a very low temperature. I can say at 175, 200 degrees centigrade, it can easily catch a fire, tar, right? That's why tar is not used. Nowadays, only bitumen is being used. So tar can easily catch a fire at 200 degrees centigrade only. But whereas bitumen will not catch fire if you go on heating till 500, which I already seen in flash and fire test in the laboratory. So tar, since whatever the heating temperature and mixing temperature of the bitumen for the aggregates will be nearer to the 200 degrees centigrade. So that's why tar cannot be used with the aggregates. So that way you can discard you can discard using of tar. Next, during the hottest weather of the region, bituminous mixture should not become too soft or unstable. Yes, so because of the hottest weather, what happens? If it gets more soft bitumen you are using in the hottest weather or in a more warmer region, then no bitumen will be left on the aggregates. So time temperature susceptible. So here it has been written with respect to warmer region, colder region. So in colder region, try to use hard bitumen. Sorry, in colder region, try to use a soft bitumen, not hard bitumen. So I can say it as for warmer region, use harder bitumen, that is having more penetration value, more ductility value, right? And whereas for cold regions, try to use harder bitumen, that is of less penetration value and less ductility value in that way. Right. Next, coming to the desirable properties, other desirable properties like presence of water, the bitumen should not strip off from the aggregate. Yes, this is one of the important, that is what I said, stripping value test, right? Or addition of bitumen, that one. That's the third property. Fourth property is adequate affinity and addition between the bitumen and aggregate used in the mix. Next, coming to the types of the bitumen. Nowadays, this is the simple classification, but different authors and different books, they classify in different ways. But this is a simple and general classification we do. One is paving grade bitumen, we say PG, paving grade bitumen. Another is industrial grade bitumen. So moving to the test on bitumen, so there are different tests, or I can say these are the common tests to be conducted, that is penetration test, ductility test, softening point test, and I will be trying to tell you the units also. Here penetration test we usually measure in 1/10th mm, 1/10th mm, 1/10th mm here, 1/10th mm. Whatever value you're getting, for example, if I'm getting 100, then it is 10 mm. Next, ductility in centimeter, ductility in centimeter. Next, softening in what? Degree centigrade. And specific gravity is unitless, right? Flash and fire point again, degree centigrade, degree centigrade, degree centigrade. And viscosity usually in seconds, is usually in seconds, is usually in seconds, right? So these all tests are very important. And as your syllabus is concerned, he has asked penetration, softening, viscosity, ductility, elastic recovery, flash and fire, and spot test. Whatever the test was there for your highway material and concrete technology lab, the same. So I'll be moving to the tests here. I will try to end this show here, and I'll try to show you the videos, because I just put the image here. Try to show you the videos so that you can understand better, because I have already explained you about these tests in the laboratory, but as the experiment is concerned, you have not conducted any trial. So that's why I want to show you the videos. I'll be trying to skip the videos wherever is required, only that I'll be showing. The apparatus required for the penetration test on bitumen. So these are the simple apparatus required for a penetration test: penetrometer, mold, and later on bitumen sample, heating pan, and later on the theory. So this all I'll be sharing with you. Procedure, coming to the procedure here, and this is the simple observation, right? So I'll move into the next 1.2. Yeah, here. So till now the apparatus required for the bitumen penetrometer test, or I can say it as penetration test on bitumen, we have discussed. So coming to the next process, so you should make sure that while once the bitumen closes separately, so you can use this digital thermometer, which is having a range of 50 degrees centigrade to 300 degrees centigrade, and later on so now the hot bitumen, which is being heated for the pouring temperature of 90 degrees centigrade, is available with us. So I have hold it with the holder, and it is in the, rather than on the machine, you can keep it on the here you can see whatever in the container, you have to pour the bitumen. At the top you have to leave about 10 mm gap, that is 10 mm. You should not fill complete container. This container leaving a 10 mm gap in the atmosphere temperature gap at the top. So now this is a hot bitumen which has to be kept for atmosphere drying in the atmosphere temperature of 25 to 30 degrees centigrade. So we can keep it somewhere aside so that there will be no disturbance to the container and the container, where aside. Keep. So you can see that the bitumen in the container is hard. It was kept for cooling in room temperature of 15 to 30 degrees centigrade for 1 hour. So whatever the poured bitumen, you should see that it is, whatever the bitumen is homogeneous and free from whites, that is air whites and water. So after pouring, it is being cooled for in atmosphere and for 1 hour at a temperature of 15 to 30 degrees centigrade. Now I am transferring the container filled with the bitumen. After cooling in atmosphere, I am transferring it to a water bath. So this is the water bath. So here you can see it is filled with the water. So completely, so that whatever the container it in a water bath with a temperature of 25 to 30 degrees centigrade for 1.5 hours. So the container with the bitumen, filled with bitumen, was kept in a. So continuing, so after 1 hour, that is, we have kept the container poured with bitumen. So trial 2. So the tip of the needle has been touched to the top surface of the bitumen filled in the container. So now we have to move this. So this can be noted as the initial reading, or else after moving this, whatever will be there, that can be noted. And actually this, both the whatever the top, this small cylinder and this should touch, both should touch, and later on you can note this as the initial reading, or you can move this needle to 0. So 400 or 0. So now we are in trial 2. So now it is been initial reading has been set to 400 or 0. Now on the machine. So after on the machine, the timer has been set to 5 seconds. So now run the machine or the bitumen penetrometer, run. So after 5 seconds, the machine will get stopped automatically, and also here it will get locked. So the machine has been stopped. Now our penetration of the needle in the bitumen. So to get the reading, move this. Move this. So when I move this, yes. So now the final reading is how much? 102. Disturb this. So you can disturb this to remove. That's the simple procedure, and already you have done this.
Results.
This observation result you can see.
One, the simple formula is n by 100, that is n into 1 by 100 centimeter. So for first trial we got 89 penetration value, so 0.89 centimeter. Depth of perception for trial 2, n by 100, so we got 102 as a value, final value. So 1 by 102 divided by 100, 1.02. So the average of both trial 1 and trial 2 will give us the 9.9 mm or 0.99 centimeter, and the grade of bitumen based upon this depth of perception values, we can say it as 80 by 100 is the grade of bitumen. That's it. Thank you.
So I have said you 1 by 10th mm for centimeter, 1 by 100th centimeter. You can note it down, right? So I'll be moving. So that is about the penetration. I already have shown you one trial in the laboratory also. I hope you remember. Next is ductility. So I'll be showing the videos again on the ductility. Sorry because we have actually I tried to combine this. It's a little bit difficult for me to merge all those videos.
So good afternoon to all of you. So today's experiment is ductility test. In this mold, the mold treatment is, this is the mold. So this is the mold. So it should be called as a briquette mold. See, in this mold, the mold dimension means the length of mold is 75 mm. The length of mold is 75 mm. So between the molds, the distance is 30 mm. Right? So in the center of the mold, so this.
So he is my colleague Vijayavu sir. I have to thank to him. He has helped me in making the other videos also. So like this is already, you know, this is the ductility machine filled with the water, right? And ductility is measured in centimeter. So already in this briquette mold, the bitumen has been filled, and whatever this bitumen filled, the briquette mold should be kept for cooling again, cooling in the atmosphere, and later on cooling in the water. The same procedure should be followed. And later on here, what we have done, we have removed all the side clamps, and also only the whatever this portion you can see there, that is only placed in the ductility machine, right? So that side, whatever the side angles, those should also be removed. We need to tighten that with the machine correctly. So you can see before there were the briquette mold, those all side angles should be removed, and only the sample and both the clamps on the either side should be there. And we need to lock the machine, and the rate of pulling will be 10 mm per minute here. So we need to on the machine there, and whatever the 10 mm per minute, the rate of pulling is constant. So you can see the whatever the pulling is been started, the rate of pulling, you can see how the bitumen on either side is been pulled. This one side will be fixed, whereas the other side will be pulled at a 10 mm per minute, the rate of pulling, right? So I'll be forwarding, right? And you already know centimeter. So this is the whatever the ruler or the scale kept on the ductility machine. Using that ruler or scale, you can easily see how much. See what happens whenever the stretching happens. The bitumen stretched from both the ends, but fixed at one end. That bitumen should not break. The thread should not break. So in that way, still till the thread gets break, we need to do the pulling. And the rate of pulling is constant. If the thread is not breaking, you can increase it to 50 mm per minute also. But 10 mm per minute is the standard rate of pulling there. So when the threads get break, stop the machine and note down the what are the value you are getting on this scale. That will be the directly the ductility value of that bitumen. See, you can see the thread, sometimes it may fail or it may directly sink into the water. So you can see 62 centimeter is the ductility value we are getting here, right? So that is what, and the sample preparation is remains the same. If you want, I'll show you the sample preparation here. You can see the hot bitumen poured into the briquette mold in this way, hot bitumen, which has been heated to 90 degrees centigrade, right? So cooling, so what we need to do, this after pouring into the briquette mold, you need to place this briquette mold in air for 30 minutes. I can say it as 30 minutes, and transfer it into the water bath for 1 hour, and later on remove it and trim it with the knife, hot knife, and again place it back in the water bath for 1.5 hours. So total 2.5 hour cooling should be done in a water bath. That is whenever I talk about the ductility test. Here you can see this all asphalt, sample, mold, and centimeter scale, right? And I missed the calculation. Just a minute. Give me a minute. Calculation, yeah. Yes, so this is the calculation. You can just try to unmute.
Coming to the observation, so for trial 1, the ductility value which we have got is around 90 centimeter, and for trial 2, 92 centimeter, and for trial 3 we got again
Here I just took an example here. No need to worry, but whatever a trial I've shown you, 62 you got. See, minimum, whatever the, sorry. So whatever the minimum ductility value required is 60 centimeters, the minimum ductility value.
In calculator, I'll try to do the average here itself. So this is how we need to do the
So that's it. The procedure with a trial conducted in the video for the aggregate ductility, bitumen ductility test there. Moving to the next is the softening point test. So here we require a ring and ball test here. So ring and ball test. Moving to the videos here. Yes, softening. Yeah, kept it separately. Yes. So I'll be muting the audio there so that I can explain clearly. And what? So, sorry. Yeah. The next again, you need to take the rings here. So you can see this is the ring and ball apparatus here, and this is the complete setup. And this is the beaker which will be filled with the water. So this is the ball, and you can see the rings also, right? So these rings in which we'll be filling the bitumen sample, and the ball will be placed on the rings. The balls will be sinking into the ring and will be falling on the base plate of the setup what I've shown. So this ring first will be filling the bitumen, and this will be placed on that ring for the placement of the ball. You can see how we have placed here, right? So we cannot directly place in the ring. That's not possible. That's why we need to place in that, and we need to place the ring. So this is a water bath. So the bitumen is being heated to a 90 degree centigrade. And if you want, you can use this glycerin for cleaning of the rings. Yes, moving to the procedure here.
So this is the way to fill this bitumen in the rings. So in the previous test, what do we do after heating the bitumen as uniformly? So then the bitumen will be transferred into the cup. So similarly here the bitumen will be transferred into the rings, right? So before pouring the bitumen in these rings, the rings will be the rings will be coated with benzene or glycerin, right? So the rings will be coated with glycerin and placed at some places. It will be cooled at it will be going to cool in a room temperature, right? Cooled in air in a room temperature. So after cooling the this bitumen, so this cooling time is will be allowing time will be 60 minutes, 60 to 90 minutes. So after that the bitumen specimen, the specimen will be placed like this here. This is the supporter and it will be placed over here. Then after that you take a ball. This is the ball. Uh, the specimen will be specimen. So this is also placed. You should be here very carefully. Softening will be close to be treated as a heating. Right? The sound ring balls. Right? Softening the bitumen. Regular temperature much of time.
So whatever the temperature is there, 50.6 is there, that is the actual temperature we'll be getting whenever the ball touches the base plate of the setup. Whatever the inside the setup is there, whenever the base plate it touches, it sinks to actually maybe by mistake sir has kept it in reverse. That should be in the reverse way, because the bitumen will be the ball will be sinking into the bitumen and it will be touching the base plate of the setup there. So maybe in the next video we have got that. Just a minute. We have actually divided among ourselves. So I was making the video and sir was explaining. Here you can see. So it has been synced to the bitumen and it has been touched the base plate. You can see clearly here, right? So at this, whenever it touches the base plate here inside the beaker, so at that, what is the temperature? That will be our softening point. Not wasting much time, I'll move to the next test on bitumen is specific gravity. Sorry, I have got this image, whatever I got, I've kept here. Yeah, so moving to this test is, yeah. So specific gravity, you can use any of the density bottle. Here there are some density bottle of 24 ml capacity, another is 25 ml capacity, or whatever the density bottle we have in your laboratory, that is 50 ml capacity with a stupor that can be used to determine the specific gravity. The procedure remains same as already I've said you. What is the procedure for the this one cement? The same procedure. So coming to the flash and fire, as already explained in the laboratory, Usually flash, the apparatus used for this flash and fire point is the whatever the Penske Martin's apparatus that is used. So the flash will be coming at a higher temperature, and later on fire will be catching. That temperature we set as flash and fire point. Coming to the viscosity test, I have already explained you with the help of the apparatus available in our laboratory, that is with the help of tar viscometer. The same sketch is available here. Like you can see here, this is the inside, that is the orifice here. So this is the orifice, right? This orifice is being closed with the help of this steel rod, the level peg we say, steel rod here. This orifice is being closed. This orifice may be of some 10 mm or 4 mm orifice, right? A hole. And below this, there will be a receiver or a small flask is kept, right? And this complete orifice is being surrounded with the water bath to keep the temperature of the bitumen constant during the test. That is around 45 to 50 degrees centigrade, right? Hot bitumen is poured. Mainly, we will not pour bitumen, we'll be pouring the cut bag directly. Cut bag means mixture of kerosene or water. Will be poured in this orifice, in this setup here, and the temperature thermometer is kept to see the temperature of the bitumen, and another thermometer has been kept here. You can see thermometer, 2 thermometers to check the temperature of the water. And this is the outside wall to remove the water and refill again. And this is the stirrer to stir the water, right? And there is a heater attached to the plug to heat the water. So what happens? The water will be heating, and that the water will be heating. The temperature of 45-50 degrees centigrade will be maintained. This whatever the level peg is there, this level peg will be removed. Just a minute. I'll try to take. So this level peg, whatever you see, the level peg, this level peg is been closing the valve. We can see here so that level peg will be removed, and the bitumen will start pouring in this receiver. So how much time it takes for pouring the 50 ml? That time will be noted. That is the viscosity. First we'll pour 25 ml, and from 25 to 75 ml, 50 ml, how much time is required? That will be the viscosity of the bitumen. That's it. So I'll be discussing about this cutback bitumen and bituminous binder in the next class, that is tomorrow. Bituminous emulsion, and later on types of bituminous emulsion, use of modified bitumen in the road construction. So if I cover this all, that will be completing unit 4, I can say. And also bituminous mixed design, Marshall mixed design. So this will be covering unit 4. Maybe in another 2 or 3 classes, I will be completing unit 4 and I will be giving the assignment. So thank you. Meeting tomorrow again. Yes, maybe the meeting is going